Okay, so good morning. 25th, today is 25th. Rehearsal for 26th Jan. Alright, let's quickly recapitulate what we have seen yesterday. Yeah, anyone? We started off with? Huh? Huh? Yeah, we saw something called as don't cares. We found that we use don't cares only if it is required as per our requirements. I mean, as per our minimization procedure. Say, for example, x can be the don't care we have represented by x, that x may be 0 or 1 depending on our minimization strategy. And please note that that x or don't care we use only if when it is required. Say, for example, here, let me go to the slide of yesterday's. Say it again. Physically. Okay, so we don't care. Either it is 1 or 0, we don't care. I mean, output, say for example, you have 5 LEDs with you, okay, and you need to represent only till numbers 15. Does that matter that fifth LED is on or off? Say for example, you need to represent your numbers, decimal numbers, from 0 to 15. Assume that, okay. You have 5 LEDs with you. 4 are sufficient. So it doesn't matter that this fifth LED glows on or off. We don't care. We are just restricting ourselves to four LEDs. That means we don't look at that. Okay, it doesn't matter. Either you keep it 0 or 1. It doesn't matter. Doesn't matter. We just ignore that. That's why we don't care. The name itself is don't care. Physically, you can represent by 0 or 1. Doesn't matter. Okay, so 24th. Right. So here we have just a comment from yesterday's class. See, I have said that there are 4 possibilities here. Consider this K map. Okay, consider this K map. I have said that I can combine this for the first one which we have combined. The first group which we have combined was this yellow one, right? Now we don't need to deliberately include this x. Okay, say for example, how many expressions are there here? You tell me. I mean, if I minimize this yellow one would be b, and this one is d bar, right? B and d bar, yellow one. Okay, yeah, and after that this green one. What is that? A bar D, right? And what else? This. Now once you cover this, this one is this 0 is also left, right? So we need to cover this white one also. So this white one is given by how much? What is that? A, C bar, D bar. Now that's not an intelligent minimization. What we would have done otherwise is, I would have grouped this and grouped that. I don't take into consideration this. So that's it. I mean, what I'm saying is, you need to consider x only when it is required. What would be the other expression for this? The minimized expression. You group this 4 zeros. Okay, just because it's not an it's the biggest group possible with this. No, just let this be pink. Pink one. Pink one is represented by A bar B. And the another one is this white one. This white one, it is represented as, yes, A, C bar, D bar. So this is more intelligent way of expressing this Boolean function. Okay, way of expressing this K map. So go for this. Don't deliberately include these don't cares. Okay, don't cares are for your for facility. Those are add-ons. Okay, use those only when it is required. Okay, don't use it deliberately. Okay, so what I'm saying is, this is not an optimal expression. This is the one which you can use, and use only till all the zeros or all the ones are covered. You don't need to deliberately cover those don't cares, because we really don't care whatever the values are there. Alright, is this clear? Alright, so let's begin today's class with a fresh. Yeah. So after that we have seen 5 variable K map, right? So this K maps can can be, because just because we are using the fundamental axioms of Boolean algebra, can be extended for any variable, for say for 6, 7, 8, okay. But after 5 variables or 6 variables, it becomes very tedious. Okay, we won't be able to judge which are the adjacent ones, because see, with 5 variables itself we were finding some difficulty. With 6 variables, we may somehow be able to somehow be able to manage that. Okay, by finding the adjacent ones. And homework for you is to find a k-map, solve a k-map with 6 variables. Okay, take any expression. How you can verify? You have that app with you, right? With that app, you can enter all the values and you can verify. Verify a 6 variable k-map. 6 variable, right? 6 variable k-map. 5 variable we have already seen. So after 6 variable, the groupings becomes very tedious. And this k-map, although it's valid for any variables, you may not be able to manually, you need some computer to compute that, okay, optimal expression. There's another method which is found to be used mostly by the computers. It's called as Quinn-McCluskey method. Okay, that we are going to see. That is another way of optimization. So Quinn. So these are two scientists, McCluskey. So method, or this is also called as tabular method. Very important one, and you have to be very careful while solving with this method. And this was invented sometimes in 1950s, I guess, 1954 something, 1950s. So this method can be well explained with the help of examples. So I request all of you to please pay attention whenever I am saying. Okay. So let's take an example which we have seen. Okay. Let's take this example. Simple example. First, understand the things. Okay. Then I'll give you time to write. No problem. First, understand the things. What I'm saying is the k-map method is okay for 5-6 variables, but after 5-6 variables it becomes tedious, so we require computer to compute the optimal expression. Computer mostly uses this tabular method or Quinn-McCluskey method. This, I mean, a bit more, what you can say is easier as compared to the k-map method, but you won't find that, I mean, while analytically solving, but for computers it may be easy. So let me note down the example: 0, 1, 3, 7, 8, 9, 11 and 15. The very first step that you need to do is, first let me write that. Step 1, observe this expression. Is it in the min term form? If it is in the min term form, then it's okay. If it is in the max term form, convert it into min term form. Okay. So organize the given expression in min term form, or summation form, or SOP form, and so on. All right. Step 2. Now we already have that, so just ignore that step. After this, you represent this each and every min term, okay, with binary representation. Do that. So let's say for 0, okay, this 0 is, so it's a 4 variable. I will write that 1. What else is there? 3, 7, 9, 11, and 15. Note it down. Okay. Yes. Oh, it is noting the variables. Okay. So let me write it nicely. It is like 8, 9, 11, 6, this decimal, or I can say minterm, and small, right? Small and j. This is binary. ABCD. Alright. Once you do that, is that okay? Once you do that, step 3. Okay. Step 3 is to form groups. Step 3 is to form groups of number of ones. Step 3 is to form a group of number of ones. The number of ones is also called as parity. Okay. Say for example, how many number of ones are there? Here 0. So form a group of zeros. So let it be a group number. So I'll write it like that. Okay. So it's a group and group of zeros. We have in zeros only one, right? I mean one term. 0, 0, 0, 0. Okay. Make anyone else is there? Any term, any other term with all zeros? I mean zero number of ones. Okay. Then okay. Once this is done, you form a group of number of ones as 1. Okay. Minterm is minterm which are having the total number of ones as 1. Okay. How many minterms are there? 1, 0, 0, 0, 1. What else? 8 is there? 1, 0, 0, 0. Anyone else? That's it? Okay, so this forms another group. Make a group of 2 ones. Tell me 3, 0, 0, 1, 1. Is that okay? Then 9, 1, 0, 0, 1. What else? That's it. Make group of 3 ones. Number of ones I said, yeah? Okay. 7, 0, 1, 1, 1. So let me write the decimal equivalents also. So this is 0, is 1, 8. What is this? 3, 9, 7. What else? 11. Yes, 11 is there. 1, 0, 1, 1. Yeah. So it is 11. Okay. So last group of 4. 15, right? 1, 1, 1, 1. Is that okay? Alright. Once you do that, this is step 3. Step 4. Now you make a partition like this. Now see here, observe first. You take each and every this groups. Okay, you compare it with the successive group. Okay, only successive, immediate next group. Okay, you compare this group with group of ones. You compare group of ones with group of twos, and so on. Okay, are you getting what I'm saying? You need to compare group of zeros, okay, with group of ones. I mean exhaustively. That means all of the group 0 members should be compared with group 1 members. All of the group 1 members should be compared with group 2 members, and so on, exhaustively. That means this 0 should be compared with 1, 8, 1 should be compared with 3, 9, and 8 also should be compared with 3, 9, and so on. Okay, exhaustively. Now, while comparing, you need to check that. Now, see, you need to find that what was the method, what was the trick that we have used in K-map. We have seen that only if adjacent squares are varying by only one variable or one bit, we are simply eliminating that, right? Same strategy we have to adopt here also. Okay, you compare first term of group 0 with first term of group 1. See where it is varying. Okay, 0 0 0 is common, but at the last digit, the d variable, it is varying, right? So you need to write the modified form of that. So modified form, I would like something like this. So 0 0 0. Now this variable is gone. I'll write it simply dash. Okay, and I'll be writing those variables which have been covered. Okay, so 0 has been matched with 1, right? Tick that, tick them, 0 and 1. That's it. Is that okay? What I'm saying? So let me tick like this, 0 and 1. All right. Now go for 0 and 8. Is only one variable varying? Only one bit is varying? Yes, one bit is varying. Where is it varying? First position. Make it dash. Rest of them are zeros. Which are the numbers? 0 and 8. 0 has already been marked. Mark 8. That's it. Okay. Grow to, now exhaustively we have finished 0 and 1 group. Okay. Now go to 1 group. You compare it with the next group. Okay. Go for the n group. Okay. So what you need to do is, you need to compare 1 with 3 and 9. You need to compare 8 with again 3 and 9. Okay. So do that. So say for example, I am taking this, which one? This 1 with 3. How many variables are varying? Now at this position, at the third bit, it is varying, right? 0 0 dash 1. So it will be 0 0 dash 1. Which variables are there? 1 and 3. Similarly, you tell me the others. Now you can proceed quickly. Tell me. 1 and 9. कौन सा variable है? Dash 0 0 1. 1 and 9. Dash 0 0 1, right? 1 and 9. Now this 3 has been covered, right? 1 and 9. Which bit is varying? Only 0. First bit is varying, right? So dash 0 0 1. So dash 0 0 1. Which are the grouping? 1 comma 9. Okay. Now 1 is covered only. Okay. Go for 8. 8 and 3. How many bits are varying? 3 bits are varying. So don't take that. 8 and 9. How many bits are varying? 1 bit is varying. Consider that. Okay. 8 and 9 is covered. So what is that? 1 0 0 dash. So it will be 1 0 0 dash. Which are the variables? 8 and. Is that okay? Group 1 and 2 is done. 1 and 2 is done. Okay. Next, go to 2 and 3. Go to 2 and 3. You need to compare 3 with the 7, 3 with the 11, 9 with the 7 and 9 with the 11. Okay, do that. 3 with the 7. How many bits are varying? So 0 dash 1 1, right? So 0 dash 1 1. Is that okay? So 3 and, so should I write 3 and 7 here? Yeah. Next, tell me. 3 and 11, how many bits are varying? So dash 0 1 1. Dash 0 1 1. So which is that? 3 and 11. So 11 is covered. Alright. Now 9 and 7. Leave it. 9 and 11. How many bits are varying? 1 0 dash 1. 1 0 dash 1. Which are the bits? 9 and 11, right? They are already ticked. Leave it. Then is the group covered? Matching of 2 and 3 is done. Go to 3 and 4. Match. Last group. Okay. Compare 7 with 15. How many bits are varying? 1. So dash 111. So dash 111. So which are the one? 7 and 15, right? So 15 is ticked. 11 and this also is varying, right? So 1 dash 1 1. So 1 dash 1 1. So it is what? 11 and, is it visible? I am not able to. This is okay? Is it visible? It's 11 and 15. Step 2 is done. Note it. किसी को भी यहाँ पे समझ में नहीं आया ऐसा कोई है? सिंपल. Try it by yourself. If more than one bit is varying, we are simply ignoring that. We are not grouping it. That's what I'm saying. The same strategy which we have used for the K-map, we have to use it here. Okay? You need to group only those two min terms which varies only in one bit. Okay? Now, see here. Now we have done the groupings of number of ones, right? You need to make the grouping of number of ones here also, okay? In the next table. So this is table 1, this is table 2, right? So see here. Can you make the group of all zeros? See here. ये group बन गया. All right. So let me mark it with different color. So all the groups with zero number of ones. Here all the group with one number of ones. ये group mark हो गया, देखो. Group with two number of ones. See here. यहाँ तक ना. Group with three number of ones and so on. Alright. Now you need to repeat the same procedure, but here you have to be careful. Here the bar should be constant while bar position should not be changing, okay, while comparing. That means you better to concentrate on this bar. You better what I'm saying is you better concentrate on this bar, okay. If I need to compare this group with this group, I need to compare this group with this group. What I need to do is go bar with bar, okay. Go for the first term, check if at this position bar is there or not. Which term the bar is there? Is यहाँ पे भी नहीं, यहाँ पे भी नहीं, यहाँ पे है ना. Now bar is matching. Now you compare the other groups, okay. Now that is varying in only first bit, right? So that will be dash 0 0 dash. Is that okay? Now you need to write dash 0 0 dash there. So it will be dash 0 0 dash. Which are the variables covered? 0 1. Now I have covered this and this one, right? So 0 1 8 9. So 0 1 8 9. Is that okay? Now tell me the other. ये bar वाला और yeah. Yes, I am explaining. See here. First, we have made the group of okay. यहाँ तक समझ में आ गया ना? I'll just proceed here. Here, what we are doing is we are forming groups of min terms having the number of ones. Okay, number of ones in binary representation. So we found that how many number of ones are there? 0, 0. Now this forms one group. Form a group with one number of ones. This. Form a group with two number of ones. That's called as parity. I'll say parity has 2. Okay. So this forms one group. This forms another group. We go by the same procedure. We need to compare the succeeding groups. Okay. Successive groups we need to compare. How? We need to exhaustively search for each min term in a group with each and every min term in the other group. Consecutive groups only. Okay. So take this min term and compare it with another min term. But here, as the bar is there or the dash or the blank dash is there, okay, because that variable has been eliminated. Because we are using the property of K-map, like xy plus xy bar is nothing but that y bar is eliminated, right? Y variable is eliminated. We are using that property. Now we have to be careful that while matching this, this bar has been at the same place. That means d has been eliminated. We can compare only that variable, that min term with the one which doesn't have that variable. That means bar, we concentrate on this bar and compare with the other terms, all three terms where the bar is there. If the bar is there, then you check for the change in the bits. Okay. Now it is varying in one bit. Okay. So we have grouped this one. It will be dash. These all three positions will be as it is. Only where it is varying again the dash. Is that okay? Now repeat that. So 0 1 8 9 is done. Now go for this. Okay. Now go for this. Okay. 0 8. Okay, you compare where it is matching with 1 9, isn't it? 1 9 it is matching. So 0 8 is matching with 1 9. So what is the expression? Dash 0 0 dash. So it's already covered, right? Dash 0 0 dash is already covered, isn't it? Leave it. Now go for group, this group and the another group. Okay, second and third group. So go for the bar. Okay, here is the bar. there is the bar. Where are they varying? So it will be dash 0 dash 1, isn't it? Dash 0 dash 1. So dash 0 dash 1. Tell me the variables. Tell me the terms. This is 1 3 and wait a minute. 9 11. This one, right? 1 3 and 9 11. So 1 3 9 11. Is that okay? Now go for the, now this one is covered, this bar is covered. Okay, और कुछ है क्या? नहीं. Take for this min term, bar at the first place. Which are the variables which we can compare? This one, right? Okay, so it becomes dash 0 dash 1. Dash 0 dash 1 is already covered. 1 3 9 1 9 11, right? Those are already covered. 1 3 9 11 already covered. Now go for this term. Okay, bar at the last one. Is there any min term which is matching? No, simply ignore that. Is that okay? Now there is a meaning for why we are putting this tick marks. Okay, now go for the last grouping. Go for the bar at the second term. Is it matching with the next one? Yes, it is matching. So dash 1 1. Okay, it becomes, now let me dash 1 1. Is that okay? Which are the groups? 3 7. Oh, okay, so not here. This one, right? 3 7 11 15. 3 7 11 and 15. All right. Then bar at the first place. So dash 1 1, that has been covered, right? Dash 1 1 has been covered. So you tick that also. All right. Next, bar at the third place. No matching. Leave it. Okay. So now we are at this one, right? Now you again follow the same procedure. Which is the procedure? I mean, you group with number of ones equal to 1 or 0. I mean 0 1 2 3 and 4. Count the number of ones. How is the group form? 0 1 and 2, right? So these are the groups. Is this matching? I mean, 2 bars matching at the same place. I mean, immediate next group में नहीं है. Go for this. 2 bars matching at same place. No. Stop. Let's stop here. Okay. Once this is done, you note down the min terms which have not been ticked. Okay. You note the min terms which have not been ticked. So which step is there? I mean, I don't know. Step 4, step 5. Next step is to check the variables which are not been covered. Can you tell me those? Have you noted this? Okay, you tell me, because I'll go to the next page. So which are those? You tell me. I'll just mark them. So only 3. ये है और ये है, right? इनमें से भी कोई रह सकता है. Okay, the terms may be from the previous tables also. Okay, just because we have ticked all of them, okay, we are not considering any of them. Okay, only tick the terms. Okay, only consider the terms which have not been checked. Okay, so these 3. You tell me this. Okay, you tell me this. 0 1 8 9. Now you form what you say. Yeah. इसका corresponding representation क्या होगा बोलो? Yeah, B bar, C bar. इसका बोलो लास्ट का C D. इसका बोलो थर्ड का. हाँ? Yes, B bar D. Right? You tell me this expressions. Okay. B bar, C bar, B bar D, C D. B bar, C bar. I'll go to the next page. So it's B bar, C bar, B bar D and C D, right? You tell me the terms, corresponding terms बोलो. इसके terms कौन से हैं? हाँ? 0 1 8 9, ठीक है? इसके बोलो 1 3 9 11. इसके बोलो 3 7 11 15, ठीक है? Make a table like this. ओके कितने सारे मिन टर्म्स, मतलब मैंने ओरिजिनल एक्सप्रेशन देखो, ओरिजिनल एक्सप्रेशन में कौन से मिन टर्म्स है बोलो, 0 1 3 7 8 9 11 15. Is it okay? Make a tabular format like this. Okay, now listen carefully. You put a cross, okay, in the boxes where this respective terms have been covered. Okay, so 0 1 8 9 here, 1 3 9 11. Tell me here, see, 3 7 11 15. Okay, now you look here, okay, very careful. Now oh हो जाता है, ठीक है. Now you encircle those crosses, okay, in which only one cross is available per column. You trace per column. In a column there should be only one cross. Check for that. Okay, can you tell me the columns which are having only one cross? 0. Then 7 is there. Then 8 15. Anyone else? नहीं है, ठीक है. Note those mean terms. Which are those? B bar, C bar, right? What else? You need to check the min terms where these crosses are there. You need to check row wise the min terms where the crosses are circled, right? So these are the two, right? B bar C and CD, right? Now see here, okay, you need to check that within this, within these two, only two are there, right? Among three, only two have been marked, right? Are these able to cover all the min terms? You check that. Okay, see, B bar C bar 0 1 8 9. You tell me for C 3 7 11 15. Are all of them covered? Stop the process. This is the final expression, F equals to. So a lot of steps are there. I'll again tell you what are the steps. Okay, just concentrate here. We'll go step by step slowly. Okay, this again I'll say that this is Quinn-McCluskey method. These were the two scientists who have discovered this method. They found that the K-map, see, for 4 variables it's like very easy process. For 5 variables we can handle. For 6 variables it becomes very tedious manually. So for computer, we need some computational power for that. Okay, for more than 5 variables, 6 variables, 7 variables, 8 variables, there will be hundreds of variables, maybe. So the nice tabular method which a computer can understand, okay, I mean it's a much nice and proper method, systematic method, is Quinn-McCluskey method or tabular method. In that, what we need to do is, once some expression has been given to you in a min term form, okay, that's okay. If it is not in min term form, organize it in min term form. Okay, that's the step 1. Step 2 is form a binary representation of each and every min term. So 0, 1, 3, 7, 8, 9, 11, 15. Each of these terms are having binary representation. Make that. Okay. Why I'm asking you that? Just because we need to group each and every. We need to form a group of 0 number of ones, 1 number of ones, 2 number of ones, and 3 number of ones. What will be the maximum group size? I mean, maximum it can go till the number of variables, right? I mean, the number of bits required to represent this, all of them min terms. It's the minimum number of bits required is 4, so it can go maximum till group 4, right? Now you need to form the group such that all these min terms are covered. Okay, in group 0 only one min term is there. In group 1 there may be 1 or 8 just because they are having equal number of ones. Okay, number of ones is 1. We form a group with 3 and 9 just because they are having 2 number of ones, and so on. Next step, we see that we compare consecutive groups. Okay, group of zeros with all members on group of ones, all members in group of ones with all members in group of twos, and so on. Only with the consecutive groups. Okay, you don't need to consider the other. You don't need to skip. You need to compare only consecutive groups. All right. Once that has been done, you need to see for the variable change. Now, see, wherever the variable change is there, you put dash there. That means that variable has been eliminated. Why? Because we have we are using that property, xy plus xy bar is nothing but x, that y has been eliminated, right? The same was used in the K-map procedure, right? So in adjacent groups, that means these forms adjacent ones. If they form adjacent one, they differ by only one bit, and that bit goes. So something like that. So 0 and 1 forms a group. Okay, they only differ in only last bit. So we put a dash there, and we continue like that. We need to exhaustively search for all, and none of the pairs should be linked. Once you form that, you repeat the same process. Now you form the group with, again you repeat the same group of 0 number of ones, 1 number of ones, 2 number of ones, and so on. Once you form this group, while comparing, when the bars are there, you make sure that the bar matches with the other group. Okay. Once you then the similar procedure is followed, you get 2 bars and so on. For each and every tabular, the bar increases. Okay, number of variables are eliminated, and while making those groupings, you make sure that you put a check mark there. Okay, that check mark indicates that min term has been covered. Okay. Now whatever the members which have not been checked, you note them, and then go to form a next table. In that table, you need to note all these groupings, the members which have not been checked, and also note the min terms which have been covered by those groups. Okay. Once you note them,